Well, I do think it's about that time. So I hope that everyone enjoyed lunch. I sure did. I thought it was great. My name is Sandi Barr, and I'm here today to talk to you about automated accessibility assurances. I got involved with accessibility because I think a lot about who has access to things and what we can do for each other in the world. And as a software engineer, what we can do for our organizations is ensuring that we create accessible software for our users. And so that's what my talk is about today. Accessibility testing is often thought about as an afterthought. It's considered to be technical debt, something to be done towards the end of a project after you build the software. But waiting until development is completed can be costly, and it can lead to unplanned rework that only then increases the time to release. Instead, though, if we account for the accessibility requirements from the start of a project and create test plans based on those requirements, we can then automate tests to ensure that what we deliver is actually accessible and remains to be accessible as it scales and evolves over time. The Web Content Accessibility Guidelines is an international standard developed by the World Wide Web Consortium, W3C, Web Accessibility Initiative, pronounced WAI, W-A-I, that explains how to make web content more accessible to people with disabilities. WCAG defines 3 levels of accessibility conformance. First is AAA, which is optimally accessible. It's the highest level and should be required as a policy for, not required, I'm sorry, as a policy for entire sites because it's not always possible to meet the level of success criteria for some content. For example, the contrast ratio between text and color backgrounds and background colors should be at least 7:1. And pre-recorded video content must have a sign language translation and audio descriptions. Websites that then meet AA standards are considered reasonably accessible by most users. Text and background color contrast must be between 4.5 to 1. And content should be presented under clear headings in a logical order, as in H1, then H2, and H3. And all elements that affect navigation need to be consistent across the site. Websites that meet level A meet the minimum level of conformance and is considered basic accessibility for every website. This includes things like keyboard navigation, providing equivalent text for non-text content. Form controls need to have labels. Content must be accessible by screen readers, and information must not be conveyed through size, shape, or color alone. The single, double, and triple A conformance levels are cumulative, meaning that to be considered AA conformant, websites must meet all success criteria for single and double A. And to be AAA conformant, all criteria must be met for single, double, and triple A. A11Y, or as you may have also heard it pronounced, ally, is a numeranym. It's shorthand for a word where the count of abbreviated letters are replaced by that numeral. It's like Kubernetes or I18N for internationalization. Although it can be much easier to type and spell, using A11Y in place of the word accessibility is not actually accessible. It fails the WCAG 311 success criteria for unusual words because certain disabilities can make it difficult to understand non-literal language. By automating assurances, I mean programmatic automated tests as opposed to manual testing performed by a person. Automated tests can validate in a matter of minutes that a new set of changes doesn't adversely affect accessibility. And continuous integration pipelines can automate checks on code repositories that reduce defects and ensure that software is delivered reliably. Have you ever wondered why our websites aren't already accessible? Why are we hesitating to solve this problem? For one, it can be too hard. As engineers, we're not all experts on accessibility, and the majority of us don't actually experience things like visual or other impairments that require the use of assistive technology, like a screen reader. So then we assume the majority of our users also aren't experiencing these challenges. And it can be too expensive. Everything from the cost of enterprise testing tools to prioritizing the effort and the rework that we talked about earlier. And often we get too stuck on our design decisions. And this is not meant as any offense to any designers. I'm sure it's not you. It's that once decisions have been made, they can be very hard to change. So thankfully, we don't have to do all the heavy lifting on our own. Today, I'm demonstrating these free and open source tools to access with accessibility testing and ensure conformance with WCAG standards and success criteria. First, we'll take a look at ESLint plugins that validate accessibility standards are met by performing static code analysis directly on your template code. Then I'll show how user-focused testing with testing library ensures accessibility in your unit tests. And finally, we'll add the Axe Core accessibility engine that automates accessibility testing against a fully running application in your end-to-end tests. These can all be used with various front-end frameworks like React, Angular, Vue, and Vite, or NX workspaces with Jest, or Vite Test and JS DOM. So first up, I'll show how the rule sets in these ESLint plugins assist with accessibility by giving developers feedback right in the code, early in the development stage. ESLint is a static code analysis tool that can efficiently audit code and flag problems based on lint rules. These rules run against precompiled code, checking to ensure the specific standards for each rule are met. These particular ESLint plugins are framework-specific because they parse and evaluate framework-specific template code. There's a comparable recommended accessibility rule set in each of these plugins, which I've listed the rules here on the screen, quite a lot of them. They can detect many common accessibility issues. The plugin for React, JSX-A11Y, came first, and this is where the rule set was initially developed and has the most comprehensive set of rules. The Vue.js accessibility plugin came later and superseded a separate Vue.js A11Y plugin that was actually no longer being maintained. The accessibility rule set for Angular is in the Angular ESLint template plugin, which will be installed and available to you if you're already using Angular ESLint. I myself am a member of the Angular ESLint organization. ESLint plugins must first be installed via NPM or your preferred package manager and enabled via configuration. Many popular workspace and build tools come pre-configured with ESLint and its recommended rule set. The plugins are enabled by adding them to the plugins configuration, and for the JSX and Vue plugins, the recommended rules are applied in the root extends configuration. ESLint supports various configuration formats like JSON, JavaScript ES modules, and also YAML. And then configurations for your various rules can be added as well as you need to maybe adjust some things for your code base. So this is an example of configuring the rule label has for the Vue.js accessibility plugin. For Angular, the template rules are configured slightly differently in this HTML override section, which applies the configuration to both inline and separate HTML template files for Angular. You'll want to look into and follow the setup for each plugin for your framework or your style of workspace. For example, for Angular, there's an ng-add schematic that will install and configure Angular ESLint for your Angular CLI project. But if you were using an NX workspace, NX handles that setup and configuration for you. So let's get into each of the rules and what they help us solve. The first rule, called alt text, checks for images to have alternative text. Image alt text needs to serve the same purpose and have the same meaning or intent as the image. Image alt text shouldn't repeat information that is nearby or from the image caption. And it's very important that we also remember to use empty alt text for decorative images. It's appropriate to use an empty alt when we have equivalent text provided adjacent to the image and the image itself would provide no additional meaning for a non-visual user. I got lots of time to tell you about alt text, but to screen reader users, less is more. Your alt text should be no longer than 125 characters. It shouldn't contain the phrase image of, include the word picture. Image is the inherent role and will be announced alongside the alt text. What should be provided is a short descriptive label describing the meaning, purpose, or intent of the image. To help figure it out, W3C provides an alt decision tree resource that helps describe how to use alt text on images in various situations. And I'll link this resource at the end. This anchor has content rule checks anchors or links to have an accessible name. The accessible name is what is read by screen readers for an element along with its role. The accessible name can be provided by text content, an ARIA label, or a child element with text content or an ARIA label. Similarly, the heading has content rule checks for headings to have an accessible name. In Angular, we have the elements have content rule, which covers both of those things and is the equivalent of the anchor or heading has content rules. This rule checks links, buttons, headings, all for accessible name. The label has associated control rule checks for labels to be associated with a form control and provide their accessible name. A form control may have more than one label, but a label can't be associated to more than one control. And you're not supposed to use labels as standalone elements without a form control. That's not their purpose. A form control then nested inside a label, as we're showing here, creates an implicit association. This rule validates implicit associations by looking for a form control element inside the label. There's also a configuration option to support any of your custom form controls you might have. A label with a matching for attribute to an ID on a form control then creates what's called an explicit association. This rule only validates explicit associations by just checking that the label has a for attribute. So it doesn't go as far as looking for a control throughout your template code to match the for and ID, actually. Static code analysis works best with nested controls where the implicit association can be validated within a single node. It's often better to prefer these implicit nested label associations wherever possible anyways, because with for and ID, you also must take care to guarantee the uniqueness of IDs throughout your page. Label has for is then the comparable rule in the Vue.js accessibility plugin. It has been deprecated in JSX-A11Y and Angular ESLint and was the predecessor of their label has associated control rules. There's also a ticket open in the Vue accessibility plugin to deprecate this rule and move to label has associated control. There's another ticket about the default configuration on this rule requiring both an explicit with matching for and ID and implicit association by nesting the form control. You must configure this rule to require only one of those checks for nesting controls or for the for and ID attributes. Applying this on top of the recommended configuration makes this label has for rule behave like the label has associated control rule. This next rule, mouse events have key events, checks for elements with mouse over or mouse out events, and ensures that they also have are paired with a focus or blur event for keyboard users. For example, like a tooltip is intended to provide clarification or missing information and needs to be shown both to mouse and keyboard users. And for screen reader users, as a side note, a clarifying tooltip should also be connected to its trigger with the ARIA described by attribute. Similarly, this rule looks for elements with click events without key events that do not otherwise have built-in keyboard support from the browser. HTML elements that support interaction have built-in keyboard support, like your button or your form controls. When a button has focus, It can be activated with the Enter or Space keys, same as clicking it with the mouse. In other words, that button's click event is activated with Enter or Space without giving it explicit key events. And an anchor link with an href can be navigated with an Enter key typically. So not only does keyboard support make interactive controls more accessible for keyboard users, but it also enables assistive technologies, like when a screen reader announces information about the focused element, or a switch device is used to navigate a web page. However, one issue I have with this rule is that its suggestion to add a keyboard listener to elements that are not inherently interactive doesn't quite improve accessibility for all users. For starters, non-interactive elements that don't have built-in keyboard support also don't receive focus by default. So this next rule is good to pair with the click events have key events rule. Interactive support's focus validates that interactive elements are actually able to receive focus, either because they have built-in keyboard support from the browser or by having a tab index to include them in the focus order. This rule passes with the tab index, but tab index is not the suggested fix because it's not actually appropriate to go at just freely throw in tab index wherever. In order to satisfy WCAG's 4.1.2 name role value criterion, you shouldn't add tab index to elements without a label that describes the contexts and a role to specify what that element is. If you have violations for this rule or the previous click events have key events rule, you should instead look to use your semantic HTML elements that already have built-in keyboard support. Or if you're building custom interactions, YARIA provides an authoring practices guide, which is a resource you can look up how to build custom widgets in a conformant manner, and I will link that resource as well at the end. Beyond ensuring keyboard support, the no static element interactions rule requires an element with click or mouse events to be a semantic HTML element with an inherent interactive role or have an explicit ARIA role assigned in order to meet the WCAG 4.2.1 name role value criteria. This rule does ensure accessibility for screen readers users and those that need other assistive technologies to rely on the accessibility APIs in the browser. Speaking of the accessibility API, next up are a few of the rules that concern ARIA roles and attributes. ARIA is an acronym for Accessible Rich Internet Applications. The purpose of ARIA is to provide information to screen readers and other assistive technologies. The first rule of ARIA is that no ARIA is better than bad ARIA. If an HTML element with the required semantics and behavior already exists, you should use that. Invalid use of ARIA can actually misrepresent an element's functionality and cause confusion for non-visual users. So if you're using ARIA to present information to the Accessibility API, be sure to follow the YARIA Authoring Practices Guide. And I'd also recommend that you build your components as shared components to be used throughout your application, and those are implemented with ARIA rather than sticking ARIA roles and attributes directly in your feature code. Using shared components can also help to create a consistent user experience across your application. This next rule validates ARIA role attributes to be valid ARIA roles. If you assign an invalid ARIA role, you can't just make things up. The API will not understand semantically what that element is. So this is a great one to pair with the previous rule for validating those ARIA attributes. There's no support yet for this in Angular ESLint, but I do plan to add it. An ARIA role defines what an element does. Semantic HTML elements have an implicit ARIA role. It is best to use those well-supported native HTML whenever you can. In your IDE, with an ESLint extension enabled, when you mouse over a violation, a red squiggly line you might see sometimes, a suggestion gets provided to you. This rule checks for elements with ARIA roles to have valid ARIA attributes. And it's telling us that this one has the required ARIA attributes. It's saying that this one has a required ARIA attribute of ARIA checked. So we have several types of ARIA roles that require different ARIA attributes to provide information, such as their state, to the API. So the combo box role requires ARIA controls for what it controls and ARIA expanded for whether or not it's open. Some roles then have built-in state when they're used with the appropriate semantic HTML elements. So for example, if we use the role switch with an input type checkbox, the required ARIA attribute ARIA checked is then implied by the checkbox's checked state. This role supports ARIA props is only available currently in the JSX rule set. Role supports ARIA props validates the assigned role supports the given properties. Even for semantic HTML elements that have an implicit ARIA role, like this input type radio, ARIA invalid is not a valid attribute for radio buttons. These are some of the additional ARIA rules that are so far only available in the React JSX accessibility plugin. These rules can be applied incrementally to improve ARIA and usage of semantic HTML elements in an existing code base, such as not allowing an element with an inherent non-interactive role, like a div, to be assigned an interactive role, like a button. Automating these lint rules gives developers accessibility guidance early on in the development lifecycle, even before the code is run. In my experience, having applied these lint rules in large code bases, developers are educated and become more aware of accessibility from the start of a project. Lint rules can run automated checks and perform fixes on our code, but human factors do have a significant role to play in accessibility and software testing to ensure that our products are designed and developed with consideration for all of our users. So in this next section, I'll demonstrate how we can use testing library to mimic user interaction and automate validation based on how our components are actually being used by our users. Testing library is a utility for testing DOM nodes, whether they're simulated as JS DOM with Jest or in the browser with other test runners. Testing library gained popularity with React, but there are testing library wrappers for other frameworks, like I'm showing Angular and Vue here and several others I certainly couldn't fit on this slide. Testing library is most commonly used in unit testing with Jest and JS DOM, but it can also then be used with other test runners and frameworks. Testing library queries the DOM in accordance to how a user would interact with the page. It can find links and buttons by their text content and form controls by their label text. Writing tests that interact with the DOM rather than your component implementation details, and in the same way that a user would use a component, gives more confidence that those tests ensure a component does what it is supposed to do for your real users. Testing the interface rather than the implementation makes for more maintainable tests. This idea is not a new one, and it applies beyond accessibility and front-end application. This quote in the screenshot is from a talk given 10 years ago by Sandi Metz at RailsConf 2013. What we're validating in accessibility testing are the programmatically determinable user outcomes, specifically the structure of HTML elements that are used by user agents and assistive technologies to extract and present information, the semantic markup, the DOM structure and relationships, ARIA roles and attributes, accessible names, and alternative text content. Tests should have assertions against interactive controls like inputs, buttons, and form controls, and they need to validate that all of these controls have the expected labels to provide their accessible names. They should simulate user events such as hover, type, or click, and then make assertions on the expected user outcomes. Testing how the interface is used is more inclusive because these tests then become accessible by default. After you do your setup and rendering in a test, the first step is typically to query the elements that you have under test, as in the elements that the user interacts with or those that will have expected user outcomes. Testing library defines a priority order for using queries that reflects the user experience of visual or mouse users, as well as those that use assistive technology. Let's take a look at each of these queries to understand more about why they have this precedence and why we may want to use them. By role should be your top choice for querying elements in your UI. You can use the name option with this query to filter elements by their accessible name, which also supports regular expression, as I have here for case insensitivity. The HTML elements like button that you'll be querying for in your user interaction test already have their implicit role defined. So I don't want you thinking here that you may need to add role attributes into your templates in order to find these elements like maybe you're doing with test IDs. ARIA roles are a predefined property of those semantic HTML elements. Querying by label validates that you have a label associated with your form control, which provides the accessible name. By display value queries form fields by their filled-in values. By placeholder text queries form fields, as you may have guessed, by their placeholder text. However, for your users, placeholder text is not an accessible substitute for a label. A placeholder does not serve as an accessible name, and it is no longer visible once a user starts typing into an input. By text should be used to query non-interactive elements by their text content, such as text in a paragraph or span, aligning to then how users read text on a page and their expected outcomes. By alt text, test things for non-visual users and queries images by their alternative text content. This query by test ID is not accessible and not otherwise advised with testing library except in cases where it's not practical to match by role, label, or text. Test IDs are an escape hatch, not a front door. Test IDs are not being presented to users and they're not part of the user experience, so I would avoid using them at all costs. Not directly related to accessibility, but I also want to mention here that in addition to the get by examples I've been showing, testing library provides these additional query variants. So it's got one set of queries for single elements and another set of all by queries that return an array. The get queries return an error when you query for an element and it's not found, whereas the query queries return null then if no elements are found. So because get by methods throw an error when they don't find an element, you want to use query by APIs to make assertions that elements are not present in the DOM. Find queries then are async, and for Angular, they'll trigger a change detection cycle for you before querying for a match. Find is a combination of get and wait for, and it will retry looking for an element up to 1,000 milliseconds, which another example in Angular can be helpful for avoiding our fake async in our tests. So once you've queried for and gathered the elements under test, following an arrange, act, assert pattern, the next step is to perform some user interaction on those elements. The Fire Event API built into testing library is actually just a lightweight wrapper around the browser's dispatch event API. And for Angular, it will also run that change detection cycle for you. The Fire Event API methods that only trigger a single event on the target element. A real user doing a key down event would first have to focus on the target and then do the key down. But Fire Event allows you to shortcut some of this and then dispatches the events directly. A lot of the times, I think Fire Event is sort of close enough for like a simple click event where the preceding user interactions can be assumed. But because Fire Event doesn't do all of the events that an actual user would go through when performing a specific action, Separately, testing library has a companion library called user event that's built on top of Fire event. User event provides methods that more closely resemble user interactions by trying to simulate all of the real events that would happen in the browser as the user interacts with it. User event describes full user interactions rather than distinct events. As part of its validation, user event also checks that elements are actually visible and can be interacted with. For example, it takes into account that browsers don't allow clicking a disabled button. Testing library recommends that developers prefer user event over Fire event because the user event API methods provide more involved and complete user interactions. For example, a user event hover simulates hovering over an element by triggering the appropriate mouse over and mouse enter events. Click hovers over the element first, then simulates all of the mouse pointer interactions to perform the click. Type simulates a user typing into an element by first focusing on the input, then doing all the key down, key up, change, and input events. To simulate the browser, user event needs to mock the UI layer and apply workarounds on top of the test environment to simulate trusted browser events that are not otherwise programmatically available. So the user event has a setup function that should be invoked at the start of each session, and then it will configure an instance of user event applying those workarounds in the configuration from the beginning. This setup function is actually newer to version 14 of user event, and in order to ease the transition, the user event API methods can still be called directly as they previously would have been, and they'll just call setup internally. So far with testing library, we've covered using queries that are accessible by default and automating simulated user interactions for our tests. Finally, we'll need to make assertions against the expected user outcomes. Expected user outcomes in software testing are defined by the ideal results that should be fulfilled once a test case has been executed. The outcomes that are tested should be relevant to the user impact and how components are used, rather than testing internal component implementation details. To that effect, JestDOM is another companion library that provides custom DOM element matchers for Jest. JestDOM's matchers allow you to write tests based on user outcomes with human readable assertions. Once installed, in order to use it in your tests, you import it once in your test setup, and then those matchers will be available to your tests. JestDOM's matchers don't even require that your queries come from testing library. It can actually work with any DOM-based testing library or framework. First assertion to be in the document is your basic check that an element was actually rendered. A lot of times, though, what I see is people using this to be visible as their basic assertion, where they seem to just be checking that an element was rendered. So I think that to be in the document would suffice for that. In addition to be present in the document, to be visible also checks for elements to not have display none, visibility hidden or collapse, or opacity 0, not to have the hidden attribute. The parent element must also be visible according to those parameters, and if it's a details element, it must have the open attribute. To me, that's a lot of extra checks to go through when you're just checking if something was rendered. These next matchers check an element's attributes, classes, and inline styles. Inline styles are rendered by JSDOM and can be validated with the toHave-style matcher. CSS, a component CSS is typically not applied by default, so you can then use the toHave class to make assertions on your conditional classes. So, for example, if you may have a CSS class that affects visibility, you can't really use that to be visible matcher because it's not going to be rendered, so you want to check the conditional class based on your assertion. The toHave focus assertion can test that the expected element has focus, or on the other hand, that elements that are not visible or are disabled are also not focusable or able to be navigated to by keyboard. Certain focus behaviors are expected in a single-page application, such as when a modal dialog is displayed, focus should be positioned into the dialog, and then when it's closed, it needs to return to the previously focused element. In single-page applications, we often perform navigation as well that results in a content update, but it doesn't refresh the entire page. So on that navigation, focus should not be moved or reset. So let's look at an example test for validating the focus is not reset after navigation. First, we're going to render the component with testing library, and for React, we'll apply the browser router wrapper. To test an Angular component with routing, you'd supply the router testing library here in the render options. Very similar. We'll click the first link and wait for the location to resolve to the routed path. And then after navigation, we'll assert that the navigated link still has focus. We're going to tab over to the next link, and then using the keyboard Enter, we will navigate the link, and after navigation, we'll assert that that second link still has focus. These matchers, to be disabled and to be enabled, look for the elements with the disabled attribute. They do not apply to the ARIA disabled attribute, which doesn't have the same behavior as disabled. The disabled attribute only applies to certain HTML elements like button, input, text area, select and their options, option groups, and field set HTML elements. To be enabled works the same as not to be disabled and helps to avoid the double negation of not disabled. To have accessible name and accessible description, check for elements to have accessible names and descriptions. Accessible names should convey the purpose or intent of an element, and it should also distinguish an element from other elements in the page. Accessible descriptions then provide additional information that complement an accessible name. An element's accessible name can come from child content, here's a test for that, an ARIA label, or by referencing content with ARIA labeled by. Here, I'm just rendering HTML for the sake of example, but it works very similarly in any of your testing frameworks. You can check getting your elements by role and validate that they have their accessible name. An ARIA labeled by also checks that you are referencing an element by ID, basically, so it's able to connect here your ARIA labeled by to the element with the category's title ID. Form controls should be paired with a label for their accessible name. Here, we're testing both implicit and explicit form control associations with the for and ID attributes. A field set with a legend provides the accessible name to a group of form controls. Tables should have a caption for their accessible name. ARIA label does work for all these too, but visible labels provide accessibility for all users. Accessible descriptions can be set with the ARIA description attribute or by referencing an element with ARIA described by. Descriptions can also be provided by the title attribute on links or form controls. However, the HTML title attribute isn't shown to keyboard or mobile users, so again, visible text descriptions provide accessibility to all of our users. When in doubt, you can actually inspect accessibility properties like name and description in the Chrome or Firefox DevTools. In Chrome DevTools, there's an accessibility pane incorporated into the Elements Inspector. You can view accessibility properties and ARIA attributes. In Firefox, the Accessibility Inspector is a separate panel in the DevTools. These ones are the structural matchers. To be empty DOM element is commonly used in the negative, as in not to be empty DOM element. To contain an element can check for elements to be descendants of other elements. To contain HTML asserts whether an HTML string is contained in an element. Testing specific DOM structure, though, is very implementation specific and not really how a user experiences your application. It can be better to assert on elements over which you have control with toContain element. To have text content, however, does align with your user's experience. You want to use to have text content on your non-interactive elements with text content, such as your paragraphs or spans. The to have text content matcher also supports regular expression for partial, case-insensitive, or explicit full content matching. These matchers check for the ARIA invalid attribute or for form elements to conform to the required type, pattern, min-max, or min and max length constraints. To have error message checks whether the element has an ARIA error message attribute that references an element with the given error message. And the rest of these matchers are also for making assertions on form controls. I've got a quick interaction user flow to help us put it all together. First, we're calling testing libraries render with the component template, and we're providing a spy to the onSubmit property. We'll initialize an instance of user event by calling its setup function. The component rendering and user event setup arrangement can also be extracted out of your spec into a setup function for convenient use in multiple specs. We're going to query for the elements under test by using the getByRole queries off of the testing library screen object. And then we'll perform user interactions on those elements. We'll type into the text box control and select options from the combo box. And then we'll assert that we have the expected values. We're going to click the button to submit the form, and we'll make the final assertions that the form data has been submitted, testing a complete user flow. That's really it. It reads well, clearly communicates intent, and directly validates the user experience and accessibility for all users by ensuring that form controls are accessible by their role and name, and that interactions are compatible with the accessibility API used by assistive technologies. So this next section introduces fully automated accessibility testing with the Axe Core accessibility testing engine. Cypress Axe is a testing library that integrates Axe Core with Cypress, a popular end-to-end testing framework. Cypress Axe injects the Axe Core accessibility engine into a page and runs an exhaustive set of tests against the, excuse me, an exhaustive set of automated tests, checking that what you would have maybe with the Axe DevTools browser extension if you were going to test things manually in the browser. Axe Core is an open source library that is used to drive other popular accessibility tools such as the Storybook A11Y add-on. I'm using Axe Core here with Cypress in order to integrate it into our end-to-end tests and run it in a fully rendered running application. The Axe Core accessibility testing engine applies all of these rules wherever it is called to check for accessibility. The fact that these run against a fully rendered application enables them to look for things like proper page structure, ensure every page has an H1 heading, and that those headings are in a hierarchical order as an H1, H2, followed by H3, and that there is only one of each of the main banner or header, content info, or footer landmarks, and that other landmarks have unique names. They can also validate ARIA usage, checking for valid, required, or allowed attributes, for required parent or children for an ARIA role, and that elements with certain ARIA roles also have a unique accessible name. This is literally all the code that it takes to inject ACT into your page and run all of those rules. You will visit the URL, inject ACTs, and then run the check A11Y function from Axe Core to validate the page's accessibility. Check A11Y also allows you to filter to specific parts of the page. You can provide a callback for extracting information for the accessibility violations, And you may also allow your test to pass regardless of failures, say if you're working toward more accessibility. Acts can also then be configured globally to exclude or include specific rules. When the Cypress tests run, if the Acts tests don't pass, they print A11Y error to the Cypress log. Clicking on these errors then prints information about the error and the relevant accessibility standards to your console log. This same information is what is returned to the check A11Y callback and then could be used to generate reports with your accessibility assessments. So at this point, we've actually built up 3 stages of assurance with linting, unit, and end-to-end tests to ensure that changes don't negatively impact software quality. And now this validation can be automated with continuous integration. I can confirm that development teams who practice continuous integration and continuous delivery to automatically build, test, and prepare frequent and small code changes for release benefit from increased efficiency and rapid software delivery. GitHub Actions is one such CI/CD platform that allows you to automate your build, test, and deployment pipeline. You can create workflows that build and test every pull request to your repository, or even deploy your merge pull request to production. You can get started with GitHub Actions with the provided templates, and here's where we're checking out one for Node.js continuous integration. And here's where we got started with that template. What it does is it basically checks out the code, sets up Node and NPM for us, runs that npm install, and then it runs each of the build, lint, test, and end-to-end steps to ensure that each of those checks pass. And if it fails it somewhere along the way, it will report what step was failed. You want to then apply this action in your PRs. So in your GitHub repo, you'll have to set a branch protection rule to require these status checks to pass before merging. With your branch protection rule set, PRs must pass status checks before merging, which you can then still override as an admin, but once your checks have passed, PRs will have a green check and the merge button is enabled. The different levels of software testing that I've discussed in our project make up our testing pyramid. The point of a testing pyramid is to encourage that we write tests with different granularities and to test less as the level increases, with fewer end-to-end tests and lots of unit tests. End-to-end tests run against your entire system. They're the most comprehensive and require the most time and resources to run. Integration tests validate that components work together but can be slow to render pages or maybe make HTTP requests. The difference between end-to-end and integration testing is how much of the system is actually under test. Parts of the system are tested in conjunction with each other in integration testing, but end-to-end tests validate the system as a whole. Cypress is an end-to-end testing framework, but in practice, we often will mock out our services to simulate API calls or different environments, which puts it more at the integration level, actually. Unit tests, like those we covered with testing library, validate a discrete unit of code to ensure the unit behaves as intended. Unit testing shouldn't depend on other components or services in the UI. And unit tests are generally fast to run and provide specific feedback, but they can only find problems at the individual unit level and can't test the system as a whole. Unit tests, though, run earlier because they're faster and in closer proximity to the components and can expose problems more quickly. Static code analysis tools like ESLint take this one step further back and validate the code itself before it even runs to ensure that developers adhere to standards like code formatting, naming conventions, type safety, in addition to the accessibility standards we've covered today. TypeScript is a static type checker, and these static tests are relatively inexpensive. It's worth mentioning Ken C. Dodd's alternate model that he calls the testing trophy that favors integration over unit testing. It's based on the idea that you should write tests, not too many, mostly integration. Integration tests give more confidence than your unit tests. Compared to unit tests, integration testing with jest can actually mean mocking fewer services or testing your parent components versus your child components. So the line between unit and integration testing can also be blurred into more of a spectrum to how much of the system is under test. So when we're unit testing, we want to test high enough up in the component tree to simulate realistic user interactions. And then we'll test the user experience and interact with application functionality rather than your specific component structure or implementation. When it comes to accessibility testing, being technically correct is not enough. Manual testing still does need to be performed to ensure that you're using semantically correct code, which can't be fully automatically detected. That all interactive elements can be used with a keyboard, that your content is arranged with a logical focus and reading order. You need to have a visible focus indicator on interactive elements that meets the contrast and display standards. You must have well-formed tables, meaningful and appropriate alt text, and how form errors are communicated, and that you're not using placeholder text as an instruction. Be sure to test with the screen reader and validate the usage of your ARIA roles and attributes to ensure that they're used correctly and, most importantly, consistently. More important, if you can, you should test your site with actual users that use assistive technologies. You'll come to understand so much more about these users and their actual experience with your software. These are some of the resources from the W3C Web Accessibility Initiative that I promised earlier. They have great tutorials on developing accessible web content. I highly, highly recommend the one on page structure. And here's the one on the alt decision tree that I promised. There's also that Why ARIA Authoring Practices guide with a complete set of ARIA design patterns and examples. I myself also published a series of articles on the Angular Dev 2 site that goes a lot more into depth and detail on each of the ESLint accessibility rules that are available for Angular. And that's really all I had for you today, and I think we have time for questions.